previous videos on this channel, we studied kinematics, which is a branch of classical mechanics that describes motion in terms of position, velocity, and acceleration. And this is done without considering the forces that cause the motion in the first place. And with kinematics, we can solve a number of interesting problems involving, but not limited to, freefall, projectile motion, circular motion, and so on. But in the next couple of videos, we're going to dive into a different area of physics called dynamics and explore Newton's 3 fundamental laws of motion. So in essence, what we really want to understand is what might cause one object to remain at rest and another object to accelerate. And we need to consider 2 main factors: the forces acting on an object and the mass of the object itself. So let's start with the definition of Newton's first law, and this is also called the law of inertia. A body at rest remains at rest, or if in motion, remains in motion at constant velocity unless acted on by a net external force. Okay, so what does this mean? So our body is anything that contains a certain amount of mass. Let's say our body is a car. And let's also draw a free body diagram to show all the external forces acting on our car object. And a free body diagram is just a sketch that shows all the external forces acting on an object or system, and comes in very useful when we want to solve problems that use Newton's laws of motion. So if our car is parked on a flat road, we only have 2 forces acting on our car. So we have the gravitational force, which is defined mathematically as the weight, which equals the mass of the car multiplied by the acceleration due to gravity. And we also have the normal force, which is the force that the surface applies to an object to support the weight of that object, and it always acts perpendicular to the surface that the object is resting on. Now, because our forces act as vectors, we can use vector addition to obtain our net external force for this particular system. And if you need a refresher on vectors, I have a list of videos in the description below. Now, because our normal force and weight have equal magnitude and point in opposite directions, our net external force sums to 0. Therefore, our car is at rest and will remain at rest because it isn't being acted on by a net external force. So let's imagine now a hypothetical situation where our car has been launched into space. Now, if this car escapes the influence of the sun's gravity, and the sun's gravity is another example of an external force, then if our car is moving at a certain velocity, then it will continue to move at the same velocity forever unless acted on by a net external force. So for example, if it collides with something, or if it experiences some other gravitational force. But if we come back to Earth and have a look at our car example, driving along the freeway, if you're driving at a constant speed and you lift your foot off the accelerator, you'll start to slow down. And that's because there's a net external force acting on your car, and we can see this in the free body diagram here. Not only do we have the force due to gravity on the car and the normal force, we also have friction within the wheels, and we have air resistance as external forces acting on our body. So when we sum up these external forces, the net force is non-zero and points in the opposite direction to the velocity of the car. In other words, the car is going to decelerate. But if you have a look at Newton's first law, it still stands. It's important to emphasize that Newton's first law can be applied to anything, and experimentation has verified that any change in an object's velocity, whether it's in motion or not, must be caused by a net external force. The last thing I want to talk about is the link between mass and inertia. Inertia is a property of an object to resist changes in its velocity. So the higher the inertia, the higher the net external force is required to modify an object's motion. So mass is directly related to inertia. And we intuitively know that because the greater the mass of an object, the harder it is to move. So in future videos, we'll cover Newton's second law and third laws, and we'll also look at how we can use these laws in conjunction with free body diagrams to solve various problems in dynamics.